My name is Eelco, like said, and I'm from an organization called PLCopen. And PLCopen deals with the efficiency in automation, especially on the control levels. So we're not in sensor levels, we're in control levels. We're not in DCS so much, we're in control levels. We're not new here. We're around 20 years now. We did a lot of issues, integration of logic, motion, and safety. We worked on exchange, and we're working now on the communication part. And that's the part I want to tell you something about. We are a worldwide organization. We're headquartered in the Netherlands. That's where I'm based. And we got an office here in North America and China and Japan. So let's say we cover the areas. The whole issue is, of course, what is this? I have somewhere some binary information and I want to know what it is. And besides that, I want to know what it is and what it represents. Not a character or a value or a part of a string. You want to know the data type to it. You also want to know how do you get access to it. You want to have easy access, transparent access. So if this is a temperature controller somewhere, a temperature value, you want to make sure that you can represent that on the higher level. So this is the control level here, where are we? And you want to represent it on a SCADA or a small panel or whatever you want to have. So in that sense, you want to do that like here before, independent from the networks. So it's not about networks, it's about communication. And it's not about data, it's about information. That's where the value gets in. So on that basis, we started the cooperation with the OPC Foundation around 2 years ago, perhaps it's now 3. Life goes faster than I'm somehow capable of matching. So we started the cooperation, and it was of course based at the OPC UA United Architecture, because then, and you saw those slides, then they were not coupled to the Microsoft stack anymore. They came up with their own ones, and since controllers are not at that level Microsoft based systems, but they got other operating systems, and you don't even want to know which operating system is there. You want to make sure that you get to the independence here. So you see the difference. We are then control, and we're matching that one. OPC UA, I hope you know where it's all about. Client-server architecture, and it creates the application session over a secure channel. That's important for us because we are going into the factories and the plants and the production lines. So, how do we do this? How do we cooperate? Because this is OPC UA. On the other side, we got a software model for IEC 61131-3, a worldwide standard about programming languages. And with that one, you see a certain structure on configuration, the whole system you need to solve your automation problem at that level. Resources in it, one or more, those are your CPUs. And you got tasks and programs and parts of programs, function blocks. And you got communication channels there. So that's how we look to a system from a software point of view. Now, what we did, we mapped our software model to the OPC UA information model, and that's a little bit of representation here. So we're here at the OPC UA level, and we are here at the deep down hardware level, where you really have nearly wired your components and where it's all going down. This is more the hardware part. You got CPUs, you got systems there. And we match that in between. Now, I don't want to go into too much detail, but again, you see here task and I cannot see it either. Configuration, resources, those items that you saw on the software model. So it is now a scan through. So you really can access a controller which contains an OPC UA server, and you can see you got somewhere in the root, you got your objects, and you got somewhere your CPU, your resources and programs, and your user-derived parts in there, and here you see your inputs and outputs and the data types that you want to have. That's what you want to know. So here's the level where you have the information going on. Now, how do we do that? What we do is, besides this mapping, you of course, and that was in another presentation also, you have somewhere your OPC UA server, and you couple that to your runtime environment, logic, motion, safety, your program, in your controller. And what you add from the compiler is this shared information, this whole list of what is going on in that program, what's running on that controller. This is where the whole software model gets in, and you link that information, so you still can use the names. You do not have to know physical addresses. It tells you all the information is there. You can access it. You can access it and scan through it. Yeah, and you don't want to have this only on one environment, you want to have this on more environments. So I had a nice demo together where you have a couple of SCADA, so the graphical representation of the program. That was a boiler demo that was running underneath under different hardwares. And if I do a representation here of that boiler demo, and let's say I take the data from this controller, but now I want to have it from the next controller. The only thing you have to change, because basically you run the same program, is the IP address. And you get the information from a different controller. It's the same way it is constructed. So in essence, that means that although you have different brands of controllers here, you have perhaps even a little bit different naming, you have the same strategy here. So you can find where you are. Here's the boiler, it's the same structure. I know where it is, I know how we named the variables, so we can find it. We can find it easily. And that means that you have the entry points into the namespace can be a little bit different, but the rest is very, very similar. So that helps you tremendously to set this all up and to organize your communication in a very transparent way. So, what are the advantages to the user? Well, you get suddenly a very transparent access to the relevant information. It's not about physical addresses, it's not about retyping. You know where it is, you can find it all, and you can use it all, what you want. And so there's less engineering time in the overall system, so not just the controller, if your overall system, if you want to do some overall equipment efficiency, if you want to couple to an HMI, like I showed there, or if you want to couple it to a higher system, like an ERP. This is not fiction. With the same demo wall, the company SAP did a live demo on how to connect to the controller and get the relevant data about the temperature into their system, live and within 10 minutes, without having to know where it is. So this is now. You don't need additional software for it. You don't need additional engineering hours for it, expensive hours. Yeah? So that's where we try to help. And you've got, of course, a transparent communication which is independent of the underlying architecture. This is not about field bus wars anymore. It is about communication, giving you access to the information that you want. So, communication will never be the same. It's the one that I like here always. Put it here also. Some words to the logo. We are on the controller level, the PLCopen as an organization. We use IEC 61131.3 software model as the basis there. OPC UA is, of course, the technology that helps us to connect to the ERP, MES, HMI system on that way. And this is how we graphically represent it as a function block, because that's a nice graphical representation of the information that's in it, how you can use it, the user interface. So that is the cooperation, OPC Foundation and PLCopen, and that indeed, from our point of view, gives you efficiency in the automation there. With that, we are not done. This is what we have. The future is now in that sense. Huh? You can do this already now. There's not a wide choice of suppliers yet, but like you see, there are coming more and more suppliers that integrate the OPC UA server in their controllers. And if they add the additionals to their compilers, then you will make sure that this works. So watch out for the logo. That's where the relevance is. But that's not where we're done. What we do now, what we're working on now, and which we show in April this year, so this is not a far-fetched future, is that we not only put the server in the controller, but also the client. And now suddenly, the client can talk to the server. So I got a PLC here or a controller that has a client and a server, and I got somewhere else in my production line a OPC server in any other controller. Now they can talk to each other. So we're creating function blocks that where you can start this application session and really can do, independent from the hardware, a machine-to-machine communication across your production lines. And we are, of course, more in the discrete area. So the room across was OMAC about packaging. This is typically what you can use on a packaging line, where you follow your information through the line. Yeah? And they can talk to each other. They can give additional information about status or what they have done or what should be done for the next stage. Yeah? Also, we are working on some name tags. One option is the OMAC name tags. There are others. There's an initiative in Germany, Austria and Switzerland that evaluated there are 500 MES systems that were in the field. And they found out that 80%, so 400 out of the 500, they could cover with around 20 tags. 20 tags, that's easy. That's a simple guidance. And with these 20 tags, if you use that in the controller programs, you get out of the box plug and play communication there. Now that's nice. For 400 of their systems, the engineering time is greatly reduced. 400 out of the 500. So we are working here, of course, too. And I like what Namur is doing there. I got to check on that, how we can integrate that in our world too. So we're not only motion lossing safety, we not only exchange. What we also do is communicate on a somewhat lower level than we do to motion. Of course, we communicate it to the motion drives, but in this case with the OPC UA. That's all from my side. Thanks.